The International Union Pure and Applied Chemistry, better known as the IUPAC, is a working group that has as members the national chemistry societies. It recognizes authority in the development of standards for the naming of chemical compounds. IUPAC has long been recognized as the world leading authority on decisions on chemical nomenclature, terminology, standards and measurements, methods, atomic masses, and many other fundamental assay data. IUPAC works with common hydrocarbons like methane, propane, butane, pentane, ethane, and ethane.
Hydrocarbons are organic compounds that consist of only carbon and nitrogen. In that compound, every carbon has 4 bonds. The carbon atoms join together to form a framework of the compound. The hydrogen atom attached to them in many different configurations. The hydrocarbons are the principal constituents of petroleum and natural gas. The hydrocarbons are distinguished based on types of bonds. Carbons divide in saturated, unsaturated, and aromatics. The saturated has 1 bond and is called alkanes. The unsaturated have 2 or 3 bonds and are the alkanes or alkenes. The aromatics has 3 bonds and has one of ethane.
Hydrocarbons which contain only single bonds. They are called saturated hydrocarbons because there is a hydrogen in various possible locations. This gives them a general formula, CnH2n+2. How to name an alkane? Find the longest carbon chain in the molecule. First, begin defining the parent chain in the molecule, that is, the longest possible chain of connecting carbons. Note that the parent chain is not necessarily the chain that simply follows from left to right. Number the parent chain. The second step is to number the carbon in the parent chain starting at the end closest to the first substituent. It is important to number the molecule from the correct end. The first 4 alkanes are methane, ethane, propane, and butane, with the level symbol shown below.
These trans isomers have a double bond of alkanes. They cannot rotate. The ethane have a double bond. This is one of the most common alkanes. The name of the alkane is 4-methyl-2-pentane. We put pentane because we have 5 components in the structure. Alkanes are a family of hydrocarbons containing a double bond. Common alkanes are ethane, propane, butane. Second position we have the double bond. In the fourth position we have a methyl. We put pentane because we have 5 components in the structure. One example of trying isomer is this. And one example of this isomer is this. And the alkanes in with this termination in this, and this also the alkanes have an hybridization of sp2 this because we have here 2 double bonds.
Before we can name alkenes, you have to know how to recognize them in a molecule. An alkene occurs when you have 2 pi bonds between the same 2 sets of carbons, also known as a carbon to triple bond. The hybridization of the carbon that holds the alkene is sp, which means that it has a bond angle of 180 degrees and the shape of the molecule will be linear. Let's try a simple alkene, for example. C, triple C single bond to H. This is fine commonly called acetylene. If you compare this to a carbon alkene, we'll have the CH single bond HC, but also we have 2 additional sets of hydrogens. As we place HP bond, we have to remove 2 hydrogens, which give the alkenes a hydrogen deficiency index of 2, and the formula of SNHN-2. This is compared to the of an alkane for SNH2n+2, to the difference of 4 hydrogens when draw an alkene in the line structure. Remember that the bond angle is 180 degrees. People will often draw an alkene in linear structure by adding two bonds, but this is incorrect, and this is because the alkene is linear and has to be drawn as a straight line when reading the structure. So don't forget that the triple starts and ends on two carbons, but also you have two additional carbons of the end of the change to name an alkene. You follow the same rules that you will for understand IUPAC naming, and that means we first identify the parent chain given the alkene occurs in the middle of the molecule. I can start numbering from the right or the left, and I have a total of 4 carbons, giving me a first name of butane. Because I have a triple bond in the molecule, I get a last name of YNI. Remember, I place number 2 in front of the name to specify where the triple bond occurs on the molecule, and this is give me a final name of 2-butane.
Compounds are also cyclic compounds with consolidated bonds, which provide them stability and also influence their chemical and physical properties. This is the benzene, that are the simplest organic compound that has 3 double bonds, that are these, and these phenyls, if released, make them a molecular standard. Examples are the naphthalene, that are these, the anthracene, that are these, and the phenphrine are these, and the aniline are these. Personal reflection, I think that the organic compounds are so important because in our community we use them a lot, and it is important to know the compound of these molecules.
As a reflection, I think it is very important to know about hydrocarbons, since hydrocarbons are a source of energy for the modern world, and also a resource for the manufacture of multiple materials with which we make our living easier.
Why hydrocarbons are important? Because they are the building blocks of everything that define modern society. They are actually too important to burn, even though we mainly use them as fuel. All modern medicine, materials science, just name a few, are synthetic products of hydrocarbons.
The name of the organic compounds is a way to gather them, to identify its properties, and to find another application in our daily life.
In final conclusion, we can say that the carbons are the basic compounds of the organisms. Hydrocarbons are an important source of energy generation for industries, for our homes, and for the development of daily lives. But they are not only fuels, we track more advanced process for the elements and separated at their use, estimate through the petrochemical industry.